Dear students, this lecture is a continuation of my WSS process lecture, but there we have seen some problems on WSS. Now I will be going to tell you what is power spectral density and how we can do the problems on that. So actually, before going to this problem, we will do a problem on how to find power spectral density if an autocorrelation is given. Okay, so just we need to know first what is power spectral density. Power spectral density is a Fourier transform. Actually, I have written the formula here. I will tell you. So, power spectral density Sxx of tau. It is denoted by Sxx of tau. Power spectral density is a Fourier transform of the autocorrelation function Rxx of tau. So, in a Fourier transform, we will be finding f of s. Actually, Sxx of omega. Here it is also a mistakenly done here. Sxx of omega. So here Rxx of tau e power minus I omega tau d tau. So if you want to find the Rxx of tau, so Fourier inverse transform you need to apply. So that formula also I will show you here. Rxx of tau is nothing but 1 by 2 pi into minus infinity plus infinity Sxx of omega e power I omega tau. So you need to be careful on writing Fourier transform and Fourier inverse transform. So here, so finding Fourier transform, just finding Fourier transform of that. So while you are writing Rxx of tau, the function is 1 minus mod tau. It is an even function. So you can write e power I omega tau as cos omega tau minus I sin omega tau. So we will be taking positive part of this function as well as this function. So even function. So we will be taking these two and we will apply Bernoulli's formula. Then we will be getting 2 by omega square into 1 minus cos omega. So that will be 1 minus cos omega can be written as sin square omega by 2. 2 sin square omega by 2, so that 2 is multiplied here. So this will be a, so Sxx of omega here should be omega. So Sxx of omega equal to Rxx of tau into e power minus I omega tau. So we found the Fourier transform. So in the other one problem, we will be going to see how to find Fourier inverse transform. Here Sxx of omega is given to you. So you need to find Rxx of tau. So the formula is like this. So that means Fourier inverse transform. So first of all, this function we need to see. It is a rational function. So rational function you can't directly integrate. So in that sense, we are using partial fraction. So that partial fraction leads to this form. This partial fraction using so before applying Fourier transform or Fourier inverse transform to this, we will see what is Fourier transform of e power minus a mod tau. So that will be 2a by a square plus omega square. This will be similar to what is the form we have here. That is why I have introduced this one here. So I have derived how to find this thing. So Fourier inverse of 2a by a square plus omega square will be e power minus a mod tau. Similar one we have to apply here. So f inverse of Sxx of omega will be this thing. So 5 by 8 is in this here. So 5 by 4 square. So 5 by 2 into this thing. So that will be 5 by 8 into f inverse of 2 into a. A will be 4. So 4 square. So 2 into 4 into 16 into omega square. This 2 is not there in the problem. So we are multiplying it. 7 by 6 f inverse of 2 into 3 by, because 2 into 3 by 3 square plus omega square. So in this form if you have, so Fourier inverse of this will be e power minus 4 tau and e power minus 3 mod tau. So this will be our Rxx of tau. So one more thing they may ask, actually average power. Average power is nothing but Rxx of 0. So at tau equal to 0 we will have Rxx of 0. So that will be e power minus 4 mod tau. That tau equal to 0 means this term will be 1. So 5 by 8 plus 7 by 6. So that will be actually given at last of this problem, I think. Let me see. Yes, here. Rx sub 0 is 5 by 8 plus 7 by 6 equal to 43 by 5, 48. Actually, that is wrong, I think. 8 6 are 48. So if you take it 43 by 24, I think. So, this problem can be solved in another method also. So this is what a Fourier inverse transform, but you can solve it in residue theorem method also. So that residue theorem method here we have been utilizing by writing this form. So we will be taking positive poles because negative poles will be out of this region. These are all you have learnt in second year course on mathematics. So some of the residues will be like this. So in this sense you will be having the same answer. So you can use either this method or that method, but Fourier inverse transform method may be easier for us. So whichever you wish, you can use it, but based on time management, you can use it in the exam. All the best. Thank you, students.